Hi, students. In this lecture, I am going to discuss problems based on total internal reflection. Let us see first one. A light ray traveling in glass medium is incident on glass air interface at an angle of instance theta. The reflected and transmitted intensities, both as a function of theta, are plotted. The correct sketch is, see the graphs given. So first we have to focus here. Light ray traveling in glass medium means traveling from denser to rarer medium, because from glass to air, okay, denser to rarer medium, right? Now see graphs carefully. So we have learned that for one angle of instance known as critical angle, light ray is grazing the surface, right? If angle of instance slightly greater than c, the light is completely reflecting, no refraction. That is now key point to identify which is a correct graph among the given graphs. Now see carefully. First graph, you can see transmission means refraction gradually decreasing, okay, which is wrong, okay. Next, coming to option D, and here also it is now decreasing gradually, which is not correct. Now coming to BC, if you observe carefully, intensity because of refraction. So transmitting is because of refraction. It is gradually decreasing. Then for one angle, drastically decrease it to zero. You can see here. This is decreasing to zero for one angle, right? Next, coming to reflection, gradual increasing at one angle. It is only reflection, right? And next coming to B, here also same graph. And again in these two, see difference carefully. Coming to C, transmission, it is not 100%, but coming to here, it is initially 100%, which is not possible. That means when angle of instance is zero, transmission is 100%. That is not possible. And coming to C, reflection non-zero, transmission less than 100, sum equal to 100. Okay, means if you take a total energy, energy reflected, energy transmitted, sum equal to 100. But coming to here, transmitting energy 100%, reflecting one non-zero. That means total value is greater than 100, which is not correct. Let us see once. Let's see carefully. Theta zero means it is instant normal. It is instant normal, right? Like this. In such a case, most of the part is now transmitting and less part is reflecting. So when you are taking intensity, because of transmission, intensity because of reflection. This is now total intensity. Okay, means which is 100%. Okay, so here what happens is reflection part is very less. When theta equal to zero, reflection part is very less, transmission part is very high, but sum equal to 100. But if you observe in the graphs, that is matching now in option C. Transmission less than 100, slightly less, reflection slightly greater than zero, sum equal to 100. This is correct. Coming to here, initially transmission is 100%, That's why this is not correct. So only option C. Okay. Right. See next one. A point source S is placed at the bottom of a transparent block of height 10 mm and refractive index 2.7. It is immersed in a lower refractive index liquid as shown in the figure. It is found that the light emerging from the block to the liquid forms a circular bright spot of diameter 11.54 mm on the top of the block. We can see diagram here. The refractive index of the liquid is asked in 2014 advance. So see the given data, height is 10 mm, refractive index 2.72. This is refractive index for the block. So we have to find refractive index of liquid, right? And given diameter is 11.54 mm, right? Let us see how to start it. So in the last class we have discussed in last lecture, we can imagine a cone, right? We can imagine a cone, and by taking the semi-vertex angle that is equal to critical angle, height equal to h, radius is r. So in that we got, or I can say once again here, tan c. Tan c is equal to r by h. And we are knowing that sin c equal to 1 by mu. Or I can say mu means this is a refractive index of the denser medium with respect to rarer medium. That means this becomes now mu r by mu denser. Okay. So now this is becoming 1 by square root of mu square minus 1. Right. From this r equal to h upon square root of mu square minus. This is what we have discussed in the last lecture, right? It is now just substituting values in this one. Let us see now. Diameter is given. So I'm multiplying both sides with a 2 because 2r gives diameter. So I'm taking values in that. Diameter is 11.54 mm. That is equal to 2h. H value 10 mm upon square root of mu square minus 1. Just substituting values in this, mm gets cancelled. Remaining is now C calculation. So from this, see what we are going to get. 11.54. And from here, what we can say is now square root of mu square minus 1 is equal to, or I can say approximately equal to root 3, right? We can see calculation 11.54 by 2, right? Now square this, mu square minus 1 equal to 3. From this mu value 2, right? Now see here what is mu. Mu in the sense mu denser by mu rarer, right? So mu denser that is given 2.72 upon mu rarer, which is nothing but refractive index of liquid in this case, that is equal to 2, right? So from this mu r is equal to 2.72 by 2, that is 1.36. Okay. So just taking r equal to h upon square root of mu square minus 1. and remain just putting values in that, we get the answer, right? Let us see next one. Right, see the question. A parallel beam of light is incident from here at an angle alpha on the side PQ of a right angle triangular prism of refractive index root 2. Light undergoes total internal reflection in the prism at the phase PR when alpha has a minimum value of 45. Condition is minimum value of 45. The angle theta of the prism is, so asked advanced 2016. Let us see how to start it. Alpha value given 45, theta we have to calculate, right? Let's see first of all the given diagram here. It is a right angled prism. Right angled prism. Now take care, this is normal at this point. Light ray is incident at some angle alpha, which is given as a 45. This is alpha, which is a 45. Light ray traveling from air to this medium. So bending towards normal. Let us take like this. So take this angle. That angle we have to calculate. So take it as R, angle of refraction. Now this is a theta which we have to calculate. Let us take at this point normal. This is normal. See what is angle of incidence here. This is alpha. Let us take here Snell's law at this boundary. Then see what we get from here. So I'm taking it as mu1. Mu1 is 1. Mu1 is 1. Sine 45. Mu1 sin I equal to mu2. Mu2 value is given as root 2, right? Is root 2 sin R. It is 1 by root 2 and root 2 here. That implies R value 30. So angle of refraction is 30. You can see this is now 90. This is 90. This is 30. Total is 120. This is 120. This is a theta. Then this remaining angle. Remaining, see how much? 120 plus theta. This is now 60 minus theta, right? This is 60 minus theta. Then this will be 60 minus theta means this is now 30 plus theta. So this is now 30 plus theta. Cross check once. 120. This is a theta. Remaining is now 60 minus theta. Then this will become 30 plus theta. Right? That is angle of incidence here. To have total internal reflection, T 30 plus theta must be greater than C. Right? Now take both sides as sine here. Sine of 30 plus theta. That is sine C, right? And in this case, C value. C equal to 45 because mu value given root 2, right? Sine C equal to 1 by mu. Mu value given root 2. That implies C value 45. C value 45. Therefore, theta greater than 45 minus 30, 15. Okay. That means theta value how much? It is a minimum 15. Okay. So we have to find the angle of the prism. So answer is now option A. Right, 15. Let us see next one. A rectangular glass slab ABCD of refractive index N1 is immersed in water of refractive index N, and condition is given that N2, sorry, N1 is greater than N2. A ray of light is incident at the surface AB of the slab as shown. The maximum value of the angle of incidence, that is alpha maximum, such that the ray comes out only from the other surface CD is given by. So asked for 2 marks in 2000. It is now diagram. Light ray is instant from this medium, right? This is N2. And condition is that N1 greater than N2, maximum value of angle of incidence such that the ray comes out only from other surface CD. That means when this reflects, means when this instant on AD, it should not come outside. That means it has to reflect completely. Then only it can come out from the face CD. That means on the face AD, it must be total internal reflection. So for that, we have to find what is alpha maximum, right? See carefully how to start it. First of all, see the diagram given. So slab is given. So this is a slab A, B, C, D. This is normal to AB. Light ray instant here. Here having refraction, then instant here. You can see this is now R, angle of refraction, and this is alpha. Let us take now Snell's law at AB boundary. Snell's law at AB boundary. See what we can write. It is N2 sine alpha, that is equal to, this is now N1, and condition given that N1 greater than N. Okay, that is equal to N1 sine R. Okay, so I'm making this one little bit bigger here. This is R. Okay, let us take it as P, and this is a Q. P, this is a Q. Take it as R. Now you can see in this triangle, this angle is now 90 minus R. So this is R, okay? Angle of refraction. So it is angle of refraction. This is R. This remaining angle is now 90 minus 90 minus R. If this angle is greater than C, then reflection takes place completely at face AC, right? Now see carefully. Sorry, this is not alpha. This is R. This is R. right? Now here what I am saying is, if alpha maximum are also maximum, because n1, n2 both are constants. So alpha maximum is R also maximum. When R is maximum, 90 minus R will be minimum. I am repeating. When R is maximum, 90 minus R will be minimum. So minimum angle at Q. If it is greater than C, then any light ray will undergo complete reflection. Okay. That means 90 minus R should be greater than C. A limiting case, it is equal to C. Right. Now substitute that here. This is equal to N1 sine, in the place of R, it is 90 minus C. That is now N1 cos C, right? And we are knowing that sine C equal to mu rarer by mu denser. So here N2 less than N1, right? It is N2 upon N1. Okay. That is now what we have to use in this case, right? That means C value how much? C value sine inverse, it is N2 by N1, right? Now substitute here, remain just calculation part. Sine alpha, this is now alpha maximum. Sine alpha maximum is equal to N1 by N2, N1 by N2 cos of C. In the place of C, sine inverse, it is N2 upon N1. From this, alpha maximum is equal to sine inverse N1 by N2 cos of sine inverse N2 by N1. Okay. So it is just taking Snell's law at the boundary AB. Okay. When alpha maximum, R is maximum, then 90 minus R is minimum. Means if minimum angle of incidence at the cube is greater than C, then light will undergo completely reflection. Right? Let us see. So this option is, it is option A, right? Correct one is option A. Let us see next one. A planar structure of length L and width W is made of two different optical media of refractive indices N1 1.5 and N2 1.44 as shown. If L is very large compared to W, a ray entering from end B will emerge from end C only if total internal reflection condition is met inside the structure. For L equal to 9.6 meter, if the incident angle theta is varied, the maximum time taken by a ray to exit the plane CD is. This is same as the previous question. When theta maximum, R also maximum. When R is maximum, 90 minus R is minimum, right? When that is greater than C, this undergoes complete reflection. So same as the previous one, but slightly it is modified. Let us see how to start it. First make a diagram, that given diagram. So you can take here now two parts. One is this is one medium. This is now second medium. And for this it is given n1, and for this it is given n2, right? N2. And this width is given, that is now doubled. Width in the sense we have take only between these 2 points, okay? Because light travels only in this region like this, right? Now it instance from here. This is angle theta. And this is now here. This is inner one is n1 and this is now n2. And this length is given L equal to, that length as given as 9.6 meter, right? So time taken how much means t into 10 power minus 9 second. The t value how much? That is what we have to calculate, right? Speed of light is 3 × 10⁸. Now see carefully how to start it. Let us make diagram separately. So it is now instant here. Angle is theta, refraction here, then instant here. This is R. Let us take normal here. So almost same as the previous problem. Now this will fall here. Let me take normal like this, right? This is R. Now this angle must be C, okay? Right. Again, when we take Snell's law, if theta is maximum, R also maximum, right? Just now we have discussed it. It is now here. So 1 into sine theta is equal to, it is now n1 into sine R. n1 is a constant. If theta maximum, R also maximum. When R is maximum, this is now 90 minus R, that will be minimum. 90 minus R, that is minimum. This value must be at least equal to C or greater than C. Okay. Then it will undergo total internal reflection. Let us take this distance as x and take this as t. From here to up to here, distance travel. Okay, this is d. Now see what we can get. If this is equal to c, then this also c, right? Then distance traveled, relation between d and x. Sine theta equal to means sine c equal to x by d. We want to calculate now distance traveled. So distance traveled equal to, it is x by sine c. Okay. So why we have taken c here means, when this is now here minimum angle. When angle is minimum, you can see d value is maximum. When sine value is minimum, total value is maximum. If I am taking like this x and next once again x, okay, like this total value is now, if I am taking an integration here, d, next will reflect like this, next reflection like this. Again, this is equal to c, this is equal to c, this is now x, and again x, next again x. If you take sum of all these x values, that gives us this total length L, right? Then d plus d plus d plus d. This is giving us, if you take sum of all this, we are going to get distance traveled by light. inside this one. Okay. That means sum of all those gives us from here what we are going to get L equal to, sorry, not L. This is that is not L. When I'm taking sum of all this, sum of all x values gives us L. Okay. I'm writing here distance traveled dt. Distance traveled equal to L upon sin C. L value is given. Now we have to focus sin C. Okay. And see what is now sin C value. Sin C value. Sin C value. Mu rarer by mu denser. Mu rarer is now N2. N2 by N1. Right. Because condition is given that N1 is greater than N2, right? Traveling from denser to rarer medium. Now substitute values in that. N1 value 1.5. N1 1.5. This is 1.44. So we have here sin C value. And L value is now, L value is given 9.6. Right? Now we have to calculate time taken, maximum time, right? So time taken equal to let us take it as a capital T. Time taken equal to distance traveled by speed. What is now speed? Speed of light in this medium. Speed of light in that medium, that is given by, I can write this is equal to C upon mu. Mu value N1. Okay. In the beginning, we have discussed a definition of refractive index. So V equal to speed of light in vacuum upon refractive index and mu value 1.5. So C value 3 10 power 8. This becomes now 2 10 power 8 meter per second, right? Now substitute that in this one. Then see what we are going to get. Distance traveled, L value 9.6. Sin C value 1.44 into 1.5, right? Upon V value 2 10 power 8. Okay. From that T value comes out to be, it is now see how much? It comes out to be 5 10 power minus 8 seconds. Okay. But is given now T 10 power minus 9. So this can be written as 50 10 power minus 9 second. That means T value, it is 50. Okay. So this question and the previous question, both are almost the same, right? So answer is now T value 50.